Okay, so this is a short conceptual video about function inverses. So I'm just going to illustrate it with an example. So let's say that you are studying abroad, if we ever get to do that again, and you're studying abroad in, say, Italy, and you're walking around and you're like, wow, it's insanely hot out here. And you ask, oh, how hot is it? And somebody tells you, oh, it's 35 degrees Celsius. And because you grew up in Delaware County, you have no idea what that means. So you say, oh, okay, what is 35 degrees Celsius? Well, I can ask my phone, 35 degrees Celsius to Fahrenheit. So I take my phone out and I say, okay, temperature converting app, tell me what is 35 degrees Celsius in Fahrenheit. And this machine, this function does something and it outputs, oh, it turns out it's 95 degrees Fahrenheit. And you say, yes, I knew that was hot. It's 95 degrees, it's really hot out. And because you grew up in a place that uses Fahrenheit, this is very natural for you. If you're given something in Celsius, you might want to convert it to Fahrenheit. So there's this function, I'll call it T for temperature, and it takes an input of degrees Celsius, and it converts it somehow to Fahrenheit. And if you learn this in school, you might have learned that the way that you convert this is you multiply by 9/5 and you add 32. And so it outputs some Fahrenheit, that's 9/5 times the Celsius plus 32. This is the definition of the function. And so this is natural for you because you grew up using Fahrenheit. But if somebody who grew up in Italy came to study abroad here, and they said, wow, it's really hot outside, how hot is it? And you told them, well, it's 95 degrees Fahrenheit. They might have the same reaction. They might say, well, I grew up in Italy. I have no idea what that means. What is 95 degrees Fahrenheit to Celsius? And so they might take out their phone, say, what is 95 degrees Fahrenheit to Celsius? And their phone might tell them, well, it's 35 degrees Celsius. Well, we hope it would tell them it's 35 degrees Celsius. And this is just as natural if you think about it. If they grew up using Celsius, they might want to convert from Fahrenheit to Celsius. And this is an example of a function inverse. So the function T that I defined here, what it does is it takes Celsius and it converts it to a Fahrenheit temperature. And it does it by this formula. And you can say, well, what is the opposite of that process? It would be taking a temperature in Fahrenheit and converting it to Celsius. So this function is moving in this direction, Celsius to Fahrenheit. And this function is moving in this direction, Fahrenheit to Celsius. And they're opposites of each other. They're inverses of each other. And the key point here is that this first function is a function, right? So if I put in an input, I get a unique output. The key point is with this particular example, if I give you a degree Fahrenheit, it corresponds to a unique degree Celsius. So for this output of the temperature function, the function T here, the Celsius to Fahrenheit function, for this output, there is only one input that maps to that output. And so I can reverse this process. When I say, what is 95 degrees Fahrenheit, there is a unique Celsius that I can map it to. And it's not ambiguous. There's 95 degrees Fahrenheit is 35 degrees Celsius, for the same reason that 35 degrees Celsius is 95 degrees Fahrenheit. And I mean, you can see sort of how I would even find the formula for this. If this is my degrees Fahrenheit, and I wanted to be given a Fahrenheit and convert it to Celsius, I could solve for C here. So I could solve for C here and get that C is F minus 32 times 5/9. And so this actually would be the formula. This would be the formula for my inverse function, that T inverse of F would be F minus 32 times 5/9.